Hello, this is Mario from Odeon. In this video, we will talk about 3D matrix calculations, available in editions Industrial and Combined. 3D matrix is a calculation that takes all of your point sources and calculates the impulse response from each source to every other source, which will be acting as receivers. In other words, it takes your point sources, treats them as sources and receivers simultaneously, and calculates the response of every possible combination of 2 points, without having to separately define receivers at the same positions. So, each point source also acts as a receiver for all other point sources. This comes in handy for open plan offices, orchestral simulations, and generally cases involving people that act as sources and receivers simultaneously. To perform a 3D matrix calculation, you simply need to click on this icon. When done, you will first see results in the 3D view. The red dot is the currently active source. The circles represent other sources, which we will call receiver sources. The color corresponds to the value for the current parameter with the current active source. You can change octave bands with the up and down arrows. And you can change the parameter with the left and right arrows. If you hover the mouse over a receiver source, you will also see the actual value. And if you double-click on a receiver source, you will make it the current active source, and the rest of the receiver sources will update accordingly. Now, let's go to the Matrix tab at the top. Here, you will see the results for all possible combinations. On the rows, you have the signal source, that is, the active source. And on the columns, you have the receiver sources. So, each row shows the values at all receiver sources with a specific active source. The color range is defined so that it spans the values at all octaves for the current parameter. But if you would like to optimize the color range for the current octave, you can use the Alt-O shortcut. The arrow key shortcuts for navigating octave bands and parameters also apply here. Although this matrix appears to be symmetrical, there can be slight differences when you invert a signal source and a receiver source. For some other parameters, like reverberation, you can get something that's not at all symmetrical. This diagonal in the matrix shows the response from a point to itself. You can also see the self responses in the 3D diagonal tab. Keep in mind that the self-responses do not include the direct sound. Since the signal source and receiver source are exactly at the same position, there is no concept of direct sound from one point to the other. With that, we conclude this tutorial, and we hope you have found it useful. Good luck!